Hi my dear students, welcome to ACE Engineering Academy ACE online platform. Myself Srikanth, faculty at ACE Engineering Academy. I am having 13 years of teaching experience in ACE Engineering Academy. I am teaching Signals and System subject. Now, welcome to today's KPTCL Signals and Systems online live session. In this session, I am going to discuss classification of systems. Okay, students? Yes. So before going to start the topic, first of all, let us see what is the syllabus of Signals and Systems subject in KPTCL course. This syllabus I have framed after analyzing the previous question papers. So after analyzing the previous question papers, so the questions are asking from these chapters. See, the syllabus is Signals chapter, Systems, third one is LTA system, fourth one Fourier series, fifth one Fourier transform, sixth one Laplace transform, seventh jet transform, eighth DFT, and nine IIR and FIR digital filters. See, in these chapters, maximum questions are asking from first signals chapter. Okay? Yes. So signals chapter means what are the different types of signals, what are the operations on signals, like that. So signal chapter is covering most of the questions. Next weighted chapter is system chapter. Next LTA system chapter. Fourier series only few questions are asking, and Fourier transform most of the questions are asking from Fourier transform chapter, and Laplace transform few questions are asking, and again jet transform asking more number of questions. Okay, yes, and DFT, IIR and FIR filters few number of questions I have asked. So this is the analysis from the previous question papers. So the most important chapters are signals, systems, LTA systems, Fourier transform, jet transform. Okay, students? Yes. This is as per the analysis of the previous question papers. Next, if you see the weightage, how many marks have given for this subject in the previous question papers, means, see students, in the 2011, 18 questions they have asked, 18 questions. So huge weightage is given. 2018, 16 questions have asked. Okay, yes. See the weightage, huge weightage is given for this subject. Okay, students? Yes. Now, let us start the today's session without any delay. See, today's session is classification of systems. Okay? Yes. So before moving to classification of systems, first of all, let us see what is meant by system. See, what is the definition of a system? System is an operator or entity which performs some operation on input signal and generates output signal. Okay, students? System is an operator or entity which performs some operation on input signal and generates output signal. If you see the block diagram of the system, see this is the block diagram of a system. See, this is system. System here I am denoting with capital T with bracket. What is capital T? Denotes its operator. Capital T denotes operator or transformation. Operator or transformation. Operator or transformation. And input signal is also called excitation. Input signal is also called excitation, and output signal is also called response. Okay? Yes. So what system is doing is, it is performing some operation on the input signal and generates output signal. Okay? Yes. What capital T means? It is operator or transformation. How to relate input and output, we'll see in the next slide. Okay? So this is a block diagram of a system. See, systems are basically two types. One is continuous time system, another one is discrete time system. If you see the continuous time system block diagram, see students, it is a continuous time system block diagram. For a continuous time system, both input signal and output signal, both are continuous time signals only. Both are continuous time signals only. So how to relate input and output in continuous time system? Y of t is equals to transformation of x of t. How to read this? Y of t equal to transformation of x of t. What capital T is called? Transformation or operation. Okay, yes. So it is performing some operation on input signal and generates output signal. So for a continuous time system, input signal as well as output signal both are continuous time signal only. Then that type of system is called continuous time system. Next, discrete time system. See students, it is a block diagram of discrete time system. Input is x of n and the output is y of n. How to relate input and output in a discrete time system is y of n equal to transformation of x of n. For a discrete time system, input as well as output both are discrete time signals only. Both are discrete time signals. Okay students? So this is a discrete time signal, this is a discrete time signal. Then only the type of system is called discrete time system. Okay students? Yes. So this is the discrete time system block diagram. Now, see, classification of systems. Totally, systems are classified into 5 types. First one is linear and non-linear systems. Second one is time invariant and time variant systems. Third one is causal and non-causal systems. Fourth one is static and dynamic systems. Fifth one, stable and unstable systems. Let us discuss one by one. Okay? Yes. See students, first one, linear and non-linear system. When a system is said to be linear system, a system is said to be linear system if it satisfies superposition or additivity property and homogeneity or scaling property. A system is said to be linear if it has to satisfy superposition or additivity property and homogeneity or scaling property. It has to satisfy 2 properties, superposition or additivity and homogeneity or scaling. So both the properties are satisfied, then only system is called linear. Even if one property is not satisfied or both the properties are not satisfied, system is called non-linear system. So this is the definition of linear and non-linear system. Okay sir, so how to check the given system is linear or non-linear? So what is the how to do the mathematical analysis? See here, see students, superposition or additivity property verification. How to verify superposition or additivity property for the given system? See, what is the input-output relationship between the system? Y of t equal to transformation of x of t. So first of all, what you have to do is, in place of x of t, you write x1 of t, then you will get y1 of t. Okay, yes. So y1 of t equal to transformation of x1 of t. And in place of x of t, you write x2 of t, then you will get y2 of t. So y2 of t equal to transformation of x2 of t. Now, in place of x of t, you write x1 of t plus x2 of t, means addition of these 2 signals, x1 of t plus x2 of t, then you assume the output is y3 of t. If y3 of t equal to y1 of t plus y2 of t, means transformation of x1 of t plus x2 of t equal to transformation of x1 of t plus x2 of t. That is, output for linear combination of inputs equal to linear combination of their individual outputs, then system satisfies superposition property. System satisfies superposition property. Output for linear combination of inputs equal to linear combination of their individual outputs, then system satisfies superposition property. So in this way, you can verify superposition theorem for continuous time system. Similarly, let us see how to verify scaling property or homogeneity property for continuous time system. See students, what is the relationship between input and output of a system? Y of t equal to transformation of x of t. Now, in place of x of t, you substitute c into x of t. What is the name of this? Scaled input. Scaled input. Okay students? Yes, scaled input. If I apply c into x of t as input to the system, I will get the output of y1 of t. What is the name of y1 of t is output for scaled input. Output for scaled input. So what is the name of y1 of t? Output for scaled input. If y1 of t equal to c into y of t, what is the name of c into y of t is scaled output. Scaled output, okay? Yes. That is transformation of c into x of t equal to c into x of t. That is output for scaled input equal to scaled output with the same scaling factor. Then system satisfies homogeneity or scaling property. output for scaled input equal to scaled output with the same scaling factor, then system satisfies homogeneity property. So you can easily understand if you solve 2-3 problems, okay? Yes. So in this way, you can verify scaling or homogeneity property for continuous time system. Similarly, for discrete time system, how to verify? Okay, see, we have verified superposition property separately and scaling property separately. By combining superposition and homogeneity, what is the condition for linearity is transformation of alpha x1 of t plus beta x2 of t equal to alpha transformation of x1 of t plus beta transformation of x2 of t. Then system satisfies linear system. So here I have combined both superposition and scaling in this equation, okay? Yes. So it is the equation. If this equation is satisfied, then system is called linear system. Okay, students? Yes. Now, see the discrete time system. Same analysis, but in place of t, I have substituted n. Okay? In place of t, just to substitute n, that's it. So it is a superposition property verification. Just I have substituted in place of t, n. Next, scaling or homogeneity property, just in place of t, substitute n. That's it. Okay? Yes. Now by combining superposition and homogeneity property, the condition for linearity is transformation of alpha x1 of n plus beta x2 of n equal to alpha transformation of x1 of n plus beta transformation of x2 of n. It is a condition for linear system. Okay, students? Yes. Now, let us see some problems. How to check the given system is linear system or non-linear system. Very, very important question. Questions are asking in the KPTCL exam. Okay? Yes. See the first problem. Okay. Check whether the following systems are linear or non-linear. See, students. Yes. How to solve this? See the solution. See. What is the question given? Y of t equal to sine of x of t. How to verify this system is linear system or non-linear system? See, students. In place of x of t, first you substitute x1 of t. Then in place of y of t, substitute y1 of t. So, y1 of t equal to sine of x1 of t. Sine of x1 of t. Okay, students? Yes. y1 of t equal to sine of x1 of t. Next, in place of x of t, substitute x2 of t. Then in place of y of t, substitute y2 of t. So, sine of x2 of t. In place of y of t, substitute y2 of t. Okay? Yes. Next, in place of x of t, substitute x1 of t plus x2 of t. So this is equals to, see here, sine of x1 of t plus x2 of t. You assume I have substituted in place of x of t, x1 of t plus x2 of t. You assume this output as y3 of t. Okay? y3 of t. First of all, what is the property I am verifying here? Superposition property I am verifying here. Okay? Yes. I am verifying superposition property. Okay? Yes. Later we will see scaling property. So I am verifying superposition property. Now tell me, students, here is y3 of t equal to y1 of t plus y2 of t means sine of x1 of t plus x2 of t equal to sine x1 of t plus sine x2 of t? No. Because sine of a plus b equal to sine a cos b, okay, plus cos a sin b. So sine of a plus b, see, y3 of t is not equal to y1 of t plus y2 of t. So here y3 of t is not equal to y1 of t plus y2 of t. Okay? Yes. So superposition property failed. Okay? Yes. So superposition property fails means no need to check for homogeneity property. Why? Why? Because both the properties are satisfied, then only system is said to be linear system. Even if one property fails, then system is non-linear system. Here superposition property fails, so system is a non-linear system. System is a non-linear system. Here I am giving one logic, students. Not only sine operator, all trigonometric operators like cos, tan, cot, any trigonometric operator is a non-linear operator because sine of a plus b is not equal to sine a plus sine b, cos of a plus b is not equal to cos a plus cos b. Like all the trigonometric operators are non-linear operator. So if any trigonometric operator are appeared in the expression, then system is by default it is a nonlinear system. Here superposition property fails, so no need to go for scaling property. Okay? Yes. This is the first problem. See the second model. See the second problem. Y of t equal to x of t into x of t minus 2. Okay, let us see the solution. Yes, see students. First, in place of, first here also I am verifying superposition property, okay? Superposition property, first I am verifying. In place of x of t, substitute x1 of t, then output is going to be y1 of t. y1 of t equal to x1 of t into x1 of t minus 2, okay? Yes. Next, y2 of t equal to x2 of t into x2 of t minus 2. Okay, students? Yes. So, in place of x, first you substitute x1 of t, then y becomes y1. In place of x, substitute x2 of t, then y becomes y2. Now, what is the thing you have to do in the third case is, what is y3 of t is, in place of x of t, you substitute x1 of t plus x2 of t. Now, tell me students how it is going to be? Yes, x1 of t plus x2 of t into x1 of t minus 2 plus x2 of t minus 2. Okay, students? Yes. Now, tell me students, is y3 of t equal to y1 of t plus y2 of t? No. Why? Because if I multiply this term, I am going to get 4 terms. Yes or not? Yes. But here if I add these two, I am getting only 2 terms. Remaining 2 terms are missing. So here y3 of t is not equal to y1 of t plus y2 of t. So system is a nonlinear system. Superposition property fails. So no need to verify for scaling property. So it is a nonlinear system. Here I am giving one logic, students. One logic. Please note down this logic. What is the logic is? Y equal to A into B form. Y equal to A into B form, where both A and B are functions of x. Where both A and B are functions of x. System is a nonlinear system. Y equal to A into B form, where both A and B are functions of x. Then system is said to be nonlinear system. Okay, students? Yes. Next. Another question. Y of n equal to x of n by x of n minus 1, discrete time system. How to verify? Yes. First to verify the superposition property. What is y1 of n, students? What is y1 of n? x1 of n divided by x1 of n minus 1. Okay? Yes. What is y2 of n? What is y2 of n? Yes. y2 of n equal to x2 of n divided by x2 of n minus 1. Okay? Yes. What is y3 of n? How to calculate y3 of n? Tell me, students. In place of x of n, substitute x1 of n plus x2 of n. So, x1 of n plus x2 of n whole divided by, in place of x of n, substitute x1 of n plus x2 of n. That is x1 of n minus 1 plus x2 of n minus 1. Okay, yes. Now tell me, students, is y3 of n is equal to y1 of n plus y2 of n? No, it is not equal. Okay, yes. If I add these two, what I am going to get? x1 of n by x1 of n minus 1 plus x2 of n by x2 of n minus 1. Okay, yes. It is not equal to y3 of n. So here y3 of n is not equal to y1 of n plus y2 of n. So superposition property fails. So it is a nonlinear system. What type of system it is? Nonlinear. What is the logic here is y equal to a by b form. Y equal to a by b form, where both a and b are functions of x. System is nonlinear system. A into b form both are function of x, or a by b form both are function of x. Then system is said to be nonlinear system. Okay, students? Yes. Next, see the next problem. Yes. Y of t equal to 2x of t plus 3. See, students, how to verify. First calculate y1 of t. Yes. y1 of t equal to 2x1 of t plus 3. 2x1 of t plus 3. What is y2 of t? What is y2 of t? 2x2 of t plus 3. What is y3 of t, students? In place of x of t, you substitute x1 of t plus x2 of t. So, 2 into x1 of t plus x2 of t plus 3, right, as it is, okay? Yes. What is y1 of t plus y2 of t? Tell me, students. What is y1 of t plus y2 of t? Tell me here. If I add these two, I can take 2 common. 2 into x1 of t plus x2 of t. 3 plus 3, how much here? Here 3 is there, here 3 is there. So it is going to be plus 6, okay? Plus 6. So y3 of t is not equal to y1 of t plus y2 of t. Why, tell me? Here 3 is there, here 6 is there. So unequal. So it is a non-linear system. What type of system it is? Non-linear system. Okay, students? Yes, it is a non-linear system. So if any constant is added like mx plus c, okay, if any constant is added, it is a non-linear system. Okay, students? Yes. Next. Y of n equal to x star of n. What is star? What is star? Conjugate, complex conjugate, okay? Yes. Let us verify first superposition. Okay, first verify the superposition. What is y1 of n? x1 star of n. What is y2 of n? x2 star of n. Okay, x2 star of n. What is y3 of n, students? What is y3 of n? In place of x of n, you substitute x1 of n plus x2 of n. Whole star, whole star. Now tell me, students, a plus b whole star equal to a star plus b star. Yes, correct. Means y3 of n equal to y1 of n plus y2 of n. Yes. So it satisfied superposition property. Superposition property satisfied. Now check for scaling or homogeneity property. How to verify? Let us see, students. I am verifying scaling property. Okay, yes. Scaling property. How to verify scaling property? See, students. What is the input-output relationship is given? Y of n equal to x star of n. Y of n equal to x star of n. What you have to do is, in place of x of n, write c into x of n. C into x of n. So in place of x of n, I have write c into x of n. Here star is there. So c into x of n whole star. This you have assumed it as y1 of n. This you assumed it as y1 of n. Okay, yes. So what is y1 of n? Output for scaled input. In place of x of n, I have substituted c into x of n. So c into x of n whole star. This is equal to c star x star of n. This is my first equation. So we have calculated output for scaled input. Now you have to calculate scaled output. What is scaled output? C into y of n. So c into, what is y of n? X star of n. So this is my second equation. Now tell me, students, is first and second equations are equal? No. Why? Because y1 of n is not equal to c into y of n. Why? Because tell me, here c star x star of n is there. Here c into x star of n is there. Here c star is there. Here c is there. See, students, when c is real, then c star equal to c. But when c is imaginary or complex, c star is not equal to c. Yes or not? Yes. So finally, even in one case it is fails, it failing the scaling property. So here scaling property is not satisfied. Superposition property is satisfied, but scaling property is not satisfied. So it is a non-linear system. What type of system it is? Non-linear system. Okay, students? Yes, even if one property is not satisfied, it is a non-linear system. See the next question. Y of t equal to x of t cos omega naught t. See, students, whether it is a linear or non-linear system. First verify the superposition property. How to verify the superposition property? Y1 of t equal to x1 of t into cos omega naught t. Cos omega naught t. Next, what is y2 of t? In place of x of t, you substitute x2 of t. x2 of t into cos omega naught t. Okay, students? Yes. What is y3 of t, students? What is y3 of t? In place of x of t, you substitute x1 of t plus x2 of t. Okay? Yes. Into cos omega naught t. Into cos omega naught t. Now tell me, students, is y3 of t is equal to y1 of t plus y2 of t or not? Yes. y3 of t equal to y1 of t plus y2 of t. Yes. If I multiply this, what I am going to get? x1 of t cos omega naught t plus x2 of t cos omega naught t. Yes. It is satisfying superposition property. Superposition property. Okay. Now let us verify the scaling property. Yes. Scaling property. So, what is the system given? Y of t equal to x of t into cos omega naught t. Okay, let us verify the scaling property. First, you calculate y1 of t. How to calculate y1 of t? What is y1 of t? Output for scaled input. Wherever x of t is there, replace with c into x of t into cos omega naught t as it is. Okay, yes. So wherever x of t is there, replace with c into x of t. What is the name for y1 of t? Output for scaled input. Output for scaled input. What is the next thing you have to find? C into y of t. What is c into y of t? C into what is y of t? X of t into cos omega naught t. Okay, yes. What is c into y of t? Scaled output. Now tell me, students, here both are equal or not? Yes. C x of t cos omega naught t, C x of t cos omega naught t. Yes. Y1 of t equal to C into y of t. Yes. So system satisfies scaling property. So both superposition property satisfied, scaling property satisfied. So system is a linear system. What type of system, students? It is linear system. Okay? Yes. Now, next question. Y of t equal to x square of t. Yes. Solve, students, solve. What is y1 of t? Tell me. First superposition. x1 square of t. Okay, students? Yes. What is y2 of t? What is y2 of t? x2 square of t. Okay, yes. What is y3 of t, students? What is y3 of t? Yes, tell me. Yes. x1 of t plus x2 of t whole square. In place of x of t, write x1 of t plus x2 of t. So x1 of t plus x2 of t whole square. Yes. So is a plus b whole square equal to a square plus b square? No. So y3 of t is not equal to y1 of t plus y2 of t. It is unequal. So system is not satisfying superposition property. No need to go for verify the scaling property. So system is a non-linear system. Non-linear system. So not only square, cube, whole power 4 and whole power 1 by 2. Whole power 1 by 2 is nothing but root. So like that, whole power, square, cube, whole power 4 or whole power 1 by 2, anything is there, it is going to be non-linear system. Okay, students? Yes. Now, see the next question. Y of n equal to log of x of n, log function. Tell me, students, what is y1 of n? What is y1 of n? Log of x1 of n. What is y2 of n? What is y2 of n? Log of x2 of n. Okay? Yes. What is y3 of n? What is y3 of n? Log of x1 of n plus x2 of n. Okay? Yes. So log of a plus b is not equal to log a plus log b. Okay? Yes. So y3 of n is not equal to y1 of n plus y2 of n. So system not satisfying superposition property. So system is a non-linear system. Okay, students? Yes. Next. Y of n equal to mod of x of n. Tell me, students, what is y1 of n? Yes, mod of x1 of n. Okay, yes. What is y2 of n? Mod of x2 of n. What is y3 of n, students? What is y3 of n? Mod of x1 of n plus x2 of n. Okay, yes. So is mod of a plus b equal to mod a plus mod b? Tell me, students. Yes, mod of a plus b is not equal to mod a plus mod b. Okay, when they are equal, both a and b are positive, or both a and b are negative, they are equal. But a is positive, b is negative, or a is negative, b is positive, they are unequal. Even in one case it is fails, it is the system is failing the superposition property. So it is a non-linear system. y3 of n is not equal to y1 of n plus y2 of n. So system is a non-linear system. Okay, students? Yes. Next. Y of n equal to exponential e power x1, e power x of n. Tell me, students, what is y1 of n? Yes, e to the power of x1 of n. What is y2 of n? Yes, e to the power of x2 of n. What is y3 of n? What is y3 of n? E to the power of x1 of n plus x2 of n. So e power a plus b is not equal to e power a plus e power b. That is, y3 of n is not equal to y1 of n plus y2 of n. So it is a non-linear system. What type of system it is? Non-linear. Exponential operator is that it is a non-linear system. Okay, students? Yes. Now, see, students, y of t equal to, suppose, dx of t by dt. dx of t by dt. It is a linear system only. It is satisfying both superposition property as well as homogeneity property. So it is a linear system. Okay, yes. Let us see the inductor. What is the input voltage, input and output? What is the current and voltage relationship in an inductor? V of t equal to L di of t by dt. Okay, yes. So it is a linear system. So you see the relationship here. This is also linear relationship. So inductor is a linear element. Inductor is what type of element? Linear element. Similarly, what is the, see this equation, y of t equal to minus infinity to t x of tau d tau. This is also linear system. This is also linear system. So voltage and current relationship in a capacitor. V of t equal to 1 by c integration of I of t dt. Yes. So it is also satisfying both superposition and homogeneity. So capacitor is a linear element. Capacitor is a linear element. Like that, resistor. V of t equal to R into I of t. It is satisfying both superposition and homogeneity principle. So resistor is also linear element. So resistor, inductor, capacitors are linear elements because they are satisfying the property of superposition and homogeneity property. Diode is a non-linear. Why? Because exponential relationship is there. Just now we have proved that exponential is a non-linear operator. Okay, students? Yes. Now, see, students, the list of non-linear operators I am giving here. Okay, yes. So just if you remember this, that's it. You can able to tell the given system is linear or non-linear. So what are the list of non-linear operators are? All trigonometric functions and whole square, whole cube, square root, okay, square root and log, exponential, modulus, complex conjugate and y equal to a by b form, both are function of x, and y equal to a into b form, both a and b are function of x. Okay, yes. So etc. Such type of functions are appeared, system is said to be non-linear system. So no need to verify if such type of functions are appeared. You can say that by default system is a non-linear system. Okay, students? Yes. So in this way you can verify linear or non-linear system when input and output relationship is given. Now see, students, here, see, just now we have seen input and output relationship given in normal form. And there is a second case that input and output relationship may be given in differential equation or difference equation form. Why, sir? Because a continuous time system is represented by using differential equation in time domain, and a discrete time system is represented by using difference equation in time domain. Okay, yes. So whenever differential or difference equations are given, how to verify the linearity or non-linearity? The technique is just, I have given the list of nonlinear operators now. Yes. So if any nonlinear operator is appeared, in the differential or difference equation, system is said to be nonlinear system. Okay, students? Yes. Now let us see with few examples you can easily understand. See the first example. Check whether the given systems are linear or non-linear. Yes, tell me, students. Think and tell me, is it linear or non-linear? See, d square is there, d square. D square is not a non-linear. dy of t by dt whole square is non-linear. Okay, yes, whole square is non-linear, but d square is not a non-linear. It is a linear operator only. D square y of t by dt square, no problem. 2 dy of t by dt plus y of t equal to x of t. No non-linear operator is appeared. Whole square, whole cube is there, it is a non-linear. But here, no such type of non-linear operators are there. So it is a linear system only. Okay, it is a linear system. Understand? Yes. Second one. Yes. See, students, dy of t by dt whole cube. See here, whole cube. There is a difference between d cube y of t by dt cube and dy of t by dt whole cube. Whole cube is there. Just now I have given a whole square, whole cube, anything is there. It is a non-linear system. Due to this, it is non-linear. And also, see, students, here, yes, a into b form, both are function of x. A into b form, both are function of x. So due to this also, it is a non-linear system. Okay, yes. So finally, system is a non-linear. What is the system? It is non-linear system. Okay, yes. See the third example. It is a difference equation. Previous one are differential equation. This is difference equation. Y of n minus 2 plus y of n into y of n minus 1 equal to x of n and x of n minus 1. Think and tell me, is it linear or non-linear? Yes, see here. Here, a into b form. A into b form. Both are function of x or both are function of y, no problem. So it is a non-linear system. See here, both are function of y or both are function of x also. Okay, okay, yes. So both are function of y. So system is a non-linear system. A into b form, both are function of x or both are function of y. System is a non-linear system. Okay, students? Yes. See one more problem. Y of n minus 1 plus n into y of n equal to x of n minus 1 plus x of n minus 2. Don't confuse here. Here a into b form is there, but n is not a function of x or not a function of y. Okay, yes. N is not a function of x and not a function of y. So it is a linear only. Okay, yes. A into b form where both a and b are function of x or function of y, then only non-linear. You see the previous example? Yes. See the previous one, a into b form, both are function of y here. But whereas you see here, a into b form is there, a is what? N. N is not a function of x or not a function of y, so no problem. So no non-linear operator is appeared here. So system is a linear system only. Okay, linear system. Okay, students? Yes. Next. See, cascade and parallel connection of non-linear system. Okay, yes. See, first see the cascade connection. What is the meaning of cascade connection? Output of first system is given to input of second system. Here I am giving some two important points. See, students, cascade and parallel connection of non-linear system. See, students, here whole square. Whole square is a linear operator or non-linear operator? Non-linear. So it is a non-linear system. Square root. Square root is also non-linear system or not? Yes. Let us assume that input is x of t here. What is output? Square is there. Means you will get square root. X square of t. X square of t is given to square root. Means what is the final output you will get? y of t equal to x of t. So finally system is linear system or not? Yes. Y of t equal to x of t, linear or non-linear? Linear. Means what I am trying to say is cascade of two non-linear system results linear system in this case. Okay? Yes. Similarly, see students here, one is exponential, another is ln, log function. This is a non-linear function, this is a non-linear function. Let us assume input is x of t. What is the output of the first system? E power x of t. What is the final output? Tell me. Pi of t equal to ln of e power x of t. How much it is? X of t only. So again y of t equal to x of t. So it is a linear system only. So in this case, cascade of two nonlinear system results linear. Okay? Yes. Now see students, in this case, whole square is a nonlinear only. So x of t, if I assume x square of t is my output, x square of t is given to exponential. So what is the final output I am getting is e power x square of t. Is it linear or non-linear? Non-linear means cascade of two non-linear systems. Here I am getting non-linear. So what I am trying to say is cascade of two non-linear systems is maybe linear or non-linear. It is not always non-linear. It may be linear or non-linear. Understand students? Yes. Next, one more important point. See students, parallel connection. See, parallel connection is nothing but this is the parallel connection. X of t, what is the, I am giving log operator. It is a non-linear system. Exponential is also non-linear system. What is the output of this? Tell me. Log of x of t. What is the output of this? E power x of t. So this is summing point. What is the final output I am getting? Log of x of t plus e power x of t. Is it linear or non-linear system? It is a non-linear system. Okay? Yes. Now see, in this case, is it linear or non-linear? 2x of t plus 2. Just now I told na, plus something is added means it is non-linear. Plus 2 minus 2. This is also non-linear. Tell me, if I add these two, what is the result I am going to get? 2x of t plus 2 plus 4x of t minus 2. 2 gets cancelled. Finally, I am going to get 6x of t. Is it linear or non-linear? Linear system. Okay, students? Yes. So parallel connection of two non-linear systems is maybe linear or non-linear. Okay? Yes. So finally, I am giving two important statements. See students here. Note. Cascade connection of two nonlinear systems is maybe linear or nonlinear, and parallel connection of two nonlinear systems is maybe linear or nonlinear. So these are the important statements. Okay, students? Yes. So before moving to time variant or time invariant systems, let us take 1 minute break. Yes. Let us continue the session. See the second classification, time invariant and time variant system. When a system is said to be time invariant system, see the definition, students. Here, a system is said to be time invariant if the input-output characteristic does not change with the time. If the input-output characteristic does not change with the time, then the type of system is called time invariant system. And the second definition is, time invariant implies that the shape of the response y of t depends only on the shape of the input x of t and not on the time when it is applied. Okay, yes. So the response depends only on the response y of t depends only on the shape of the input x of t, but it does not depending upon the time when it is applied. Okay, yes, it is a second definition. And the third very important is, input is delayed by t0 units. Let us assume output is also delayed by the same amount. Then the type of system is called time invariant system. I am explaining these definitions with one example. You can easily understand. See, students, here let us assume that this is input x of t, this is input x of t, okay, yes, and this is output y of t you are getting. Let us assume for this input you are getting this output, for this input you are getting this output. Next time what I am doing is, I am shifting the input by t0 units. T0 is nothing but how much I am doing here? 2 units. I am shifting the signal to the right side by 2 units. Suppose if it is a time invariant system, TIV is nothing but time invariant, okay, yes. Output is also shifted by the same amount. Output is also shifted by the same amount. That is, you see here, initial value where it is started 0. So 0 moves to 2, 2 moves to 4. Understand, students? Yes. What is meant by time invariant system? Input is shifted by how many units? Output is also shifted by the same amount. There is no change in the shape. There is no change in the shape. Okay, yes. So shifting the input equal to shifting the output, then the type of system is called time invariant system. Okay, students? Yes. Let us see how to verify the given system is time variant or time invariant for continuous time system. See, students, here what is the input-output relationship between a system? Y of t is equals to transformation of x of t. Y of t equal to transformation of x of t. Now, you give some delay in the input. I am noting it as x of t minus t naught. I am giving some delay in the input, that is x of t minus t naught. Let us assume that output is y1 of t. What is the name for y1 of t? Output for shifted input. What is the name for y1 of t? Output for shifted input. Now, what you have to do is, if y1 of t equal to, if y1 of t equal to y of t minus t naught, y1 of t equal to y of t minus t naught, then that system is called time invariant system. System is called what? Time invariant system. What is the name for y1 of t? Output for shifted input. What is the name for y of t minus t naught? Shifted output, okay, shifted output. In both cases, shifting parameter is same. So output for shifted input equal to shifted output, then the system is called time invariant system, okay, yes. Let us see how to verify for discrete time system. Discrete time system verification. See, students, what is the input-output relationship between a system? Y of n equal to transformation of x of n. Let us give some delay in the input, x of n minus n naught. I am giving a delay of n naught units. Let us assume the output as y1 of n, okay, y1 of n. What is the name for y1 of n? Output for delayed input. If y1 of n equal to y of n minus n naught, y1 of n equal to y of n minus n naught, output for shifted input equal to shifted output, then system is called time invariant system, TIV system. Okay, students? Yes. Output for shifted input equal to shifted output, then system is called time invariant system. If you solve 2-3 examples, you can easily understand. See, students, here, now test the following systems for time invariant. See how to verify. See, students, first you have to find y1 of t. What is y1 of t? Output for shifted input. Simple logic I am telling. See, students, wherever input is nothing but x, output is nothing but y. Please remember, input is nothing but x, output is nothing but y. Wherever x is there, delay by t naught units. Here x is there. So x of t minus t naught into cos 3t. You note down this as y1 of t. You note down this as y1 of t. Okay, yes. Now next you have to calculate y of t minus t naught. Y of t minus t naught. Wherever t is there, replace with t minus t naught. So x of t minus t naught into cos of 3 into t minus t naught. So in this case, y1 of t is not equal to y of t minus t naught. So system is a time variant system. TV is nothing but time variant. TIV is nothing but time invariant. Okay, yes. So once again, see students, how to calculate y1 of t. Wherever x is there, delay by t naught units. How to calculate y of t minus t naught? Wherever t is there, replace with t minus t naught. Okay, students? Yes. So in this case, it is a time variant. See the second question. Y of t equal to t into x of t. Tell me students, what is y1 of t? Wherever x is there, delay by t naught units. T into x of t minus t naught. Okay, na? Yes. What is y of t minus t naught? Wherever t is there, replace with t minus t naught. T minus t naught into x of t minus t naught. Are both are equal? No. So y1 of t is not equal to y of t minus t naught. So system is a time variant system, TV system. Okay? Yes. Next. See the third question. Y of n equal to e power x of n. Yes. Tell me students, what is y1 of n? Wherever x is there, delay by n naught units. X of n minus n naught. Wherever x is there, delay by n naught units. Now, what is y of n minus n naught? Wherever n is there, replace with n minus n naught. E power x of n minus n naught. E power x of n minus n naught. So here, y1 of n is equals to y of n minus n naught. So system is a time invariant system, TIV system. Okay? Yes. Next. Y of n equal to x of 2n. Yes, tell me students, what is y1 of n? Wherever x is there, delay by n naught units. 2n minus n naught. Just x is delayed by n naught units. Next, you have to calculate y of n minus n naught. Wherever n is there, replace with n minus n naught. Okay, yes. So this is equals to x of 2n minus 2n naught. Are both are equal? No. So y1 of n is not equal to y of n minus n naught. So it is a time variant system. Okay, students? Yes. See the next question. Y of n equal to x of minus n. Yes. Tell me students, what is y1 of n? Wherever x is there, delay by n naught. Don't confuse here. Just x is there, delay by n naught. X of minus n naught. What is y of n minus n naught? Tell me students. Wherever n is there, replace with n minus n naught means minus of n minus n naught. So this is equals to x of minus n plus n naught. Are both are equal? No. So y1 of n is not equal to y of n minus n naught. So system is a time variant system. Okay? Yes. Next. Y of n equal to x of n square. Tell me students, what is y1 of n here? What is y1 of n? Wherever x is there, delay by n naught units. X of n square minus n naught. What is y of n minus n naught? Tell me. Wherever n is there, replace with n minus n naught. So n minus n naught whole square. So y1 of n is not equal to y of n minus n naught. So system is a time variant system. Okay? Yes. Next. Y of n equal to x of n into g of n. Very, very important. See here. See here. Input is x. G is not a input. It is some other function. Okay? Yes. So what is y1 of n? Wherever x is a delay by n naught units. Don't change anything in g of n. Okay, yes, g of n keep as it is. What is y of n minus n naught? What is y of n minus n naught? Wherever n is there, replace with n minus n naught. X of n minus n naught into g of n minus n naught. Yes. So in this case, both are unequal. Y1 of n is not equal to y of n minus n naught. So system is a time variant system. System is a time variant system. So in this way, you can verify time invariance and time variant systems. Okay? Yes. Now, see students here, now see here, up to now we have seen input-output relationship given in normal form. Now, whenever differential equation or difference equations are given, how to verify that time variance or time invariance? See students, here, if all the coefficients of the differential or difference equation are constants, okay, constants, then the system is said to be time invariant system. Even if one coefficient is function of time, then system is called time variant system. Okay, yes, all the coefficients must be constants, then only time invariant. Even if one function or many functions are function of time, it is a time variant system. Let us see here. Check whether the given systems are time invariance or time variance. It is differential equation is given. What is the coefficient of this here? 1. What is the coefficient here? T square. It is a function of time or not? Yes. Even if one coefficient is function of time, it is a time variant system. It is a time variant system. Okay, students? Yes. Now, see the second question. See, what is the coefficient of this? 1. What is the coefficient of this 2? What is the coefficient of this 3? What is the coefficient of this 5? All are constants. So, system is a time invariant system. Okay? Yes. Next. See students. What is the coefficient of this? 1. What is the coefficient of this? 1. What is the coefficient of this? 1. All are function of time only. So system is a time invariant system. Okay, yes, it is d square y of t by dt square. Okay, yes, all are constants only. So system is a time invariant system. Next, see students, next, what is the coefficient of this? It is a difference equation 1. What is the coefficient of this n minus 1? N is nothing but time. In the continuous case, t is a time. In the discrete case, n is a time. It is a function of time. So system is a time variant system. System is what type of system? Time variant system. Okay, students? Yes. Now, cascade and parallel connection of time variant systems. See students, cascade connection. See, what is mean by this is a time variant system. This is also time variant system. What is this time variant? Compression by 3. Nothing but if I give x of t as a input, compression by 3 is nothing but what is the output you will get is x of 3t. Expansion by 3 is nothing but x of 3t by 3. So finally what is the output I am getting? Y of t. So final output what I am getting? X of t. So cascade of 2 time variant system is time invariant system in this case. Okay? Yes. So similarly, see one more example. See here, this is 2x of t plus t. It is a time variant system. It is a time variant system. Parallel connection of 2 time variant system. What you have to do? Addition. 2x of t plus t, 4x of t minus t. Tt gets cancelled. So finally you are getting 6x of t, 6x of t. So it is also time invariant system. So finally what is the statement I am giving means, see students here, cascade connection of 2 time variant systems is maybe time invariant or time variant. Similarly, parallel connection of 2 time variant systems is maybe time invariant or time variant. Similar as linear systems. Okay, yes. So cascade connection of two time variant system is maybe time variant or time invariant. Parallel connection of two time variant systems is maybe time variant or time variant. So this is about time variance and time invariant systems. So let us take 1 minute break, students. See the next classification, causal and non-causal systems. When a system is said to be causal system, see students, a causal or non-anticipating system is one whose present output does not depend on future values of the input, okay? Yes, means when a system is said to be causal system means present output depends only on present and past inputs, okay? Present and past input, it does not depends upon the future values of the input. Suppose if present output depends on future values of the input, system is said to be non-causal system, okay? Yes. Let us see with few examples. See here. Check whether the following systems are causal or non-causal. So how to verify is, you have to substitute three different values of time. One negative, one zero, one positive. Let us see here. Substitute one negative value, y of minus 1 equal to x square of minus 1, and substitute one 0, y of 0 equal to x square of 0, and y of 1 equal to x square of 1. So in all the three cases, once you see here, for minus 1 is a present, for 0 is a present, for 1 is a present. In all the three instances, present output depends on present input only, so it is a causal system. What type of system it is? Causal. Next, see the second example. Yes, y of t equal to x of sin t. Here, very important. What is the argument for x? Sin t. So, if I substitute t equal to minus pi, one negative value, what is y of minus pi value? Tell me. X of sin of minus pi. What is the value of sin of minus pi? Tell me, students. Is it 0 or not? Yes. So y of minus pi equal to 0. Now this becomes the index of x. For minus pi, 0 is a future value. So it is future input. Okay, it is a future input. So system is a non-causal system. Okay, non-causal system. Okay, students? Yes. Now, y of n equal to x of n square. Tell me, students, substitute one negative value. Y of minus 1 equal to x of 1. Y of minus 1 equal to x of 1. Tell me, students, for minus 1, 1 is a future input. So system is a non-causal system. Okay, non-causal system. Okay, yes. Next, y of n equal to x of n into g of n plus 2. Here we need to concentrate only on input. G is not a function of input, so no need to calculate that. Now tell me, students, y of minus 1 equal to x of minus 1 and y of 0 equal to x of 0 and y of 1 equal to x of 1. So in all the instances, present output depends only on present input. So it is a causal system. What type of system it is? Causal. Okay, students? Yes. Next, y of t equal to mod of x of t. Tell me, students, what is y of minus 1? Mod of x of minus 1. What is y of 0? Mod of x of 0. What is y of 1? Mod of x of 1. So in all the instances, present output depends on present input only. So it is a causal system. What type of system, students, it is? Causal system. Okay, yes. Suppose if the signal system is given like this, y of t equal to x of mod of t. Now tell me, students, what is y of minus 1? X of 1. Future input. So it is a non-causal system. Okay, yes. It is a non-causal system. Next one. Okay, y of minus 1 equal to x of 2n. What is y of minus 1? X of minus 2. So present output depends on, what is this? Past input. It is a past input. For minus 1, minus 2 is a past. What is y of 0? X of 0. So 0, 0 means present. Okay, present. What is y of 1? What is y of 1? X of 2. For 1, 2 is a future. Okay, future. So future. So here, even in one instance, if it depends upon the future, so system is a non-causal system. In the total 3 cases, if it depends on present and past, then only it is a causal system. Even in one instance or more than one instance, if it depends upon the future input, system is a non-causal system. Okay, students? Yes. Next. Static and dynamic system. Static and dynamic system. When a system is said to be static, system is nothing but present output depends only on present input, then only system is static. If present output depends on either past or future inputs, then system is said to be dynamic. So similar type of, okay, static systems are called memory-less or instantaneous systems. Okay, yes. And dynamic systems are called memory systems. Okay, memory systems. Now, all static systems are called causal systems, but not vice versa. All static systems are called causal systems, but not vice versa. Okay, students? Yes. Now, let us see the verification. Same analysis, students. Tell me here, what is y of minus 1 here? X of minus 3. Tell me, students, for minus 1, minus 3 is a past input. Yes or not? Past input. So present output depends on past input. So it is a dynamic system. What type of system it is? Dynamic system. Okay? Yes. Next. Second one. Y of t equal to minus infinity to t x of tau d tau. See, students, here let us substitute one negative value. Y of minus 1 equal to minus infinity to minus 1 x of tau d tau. Y of 0 equal to minus infinity to 0 x of tau d tau. What is y of 1? minus infinity to 1 x of tau d tau. Let us see carefully, students, here. What is the index for x? Tau. What are the tau limits? Minus infinity to minus 1. What is my present output? Minus 1. For minus 1 is a present input and less than minus 1 are past inputs only. Okay, yes. So present output depends on present input and past inputs. Here also say present output depends on present input and past inputs. Present output depends on present input and past inputs. So in all the cases, present output depends on present and past. So system is a dynamic system. What type of system, students? It is dynamic system. Okay, yes. Now, yes, how to verify static or dynamic systems when differential or difference equations are given? By default logic, students, whenever system characterized with differential equation or difference equation, by default it is a dynamic system. By default it is a dynamic system. A system described by differential or difference equation system is a dynamic system. Okay, yes. So now find whether the following systems are linear, time invariance and dynamic. Just by using the given logics, just tell me, students, directly what type of system it is. Is there any nonlinear operator is appeared? No. So it is a linear system. Is it time variant or invariant? Here it is a function of time is there. So it is a time variant. Is it static or dynamic? It is described by using differential equation. So it is a dynamic system. Okay, yes. Now tell me, students, is there any nonlinear operator is appeared? No. So it is a linear system. Linear system. And what are the coefficients here? 1, 4, 2. All are constant. So it is a time invariant system. It is described by using differential equation. So it is a dynamic system. What type of system it is? Dynamic. Tell me, students, what about this one? No nonlinear operator is appeared. So it is a linear system. What are the coefficients? 4, 2, 1, 3. All are constants only. So system is a time invariant system described by using differential equation. So it is a dynamic system. Okay, yes. Here you see whole square is there. So nonlinear operator. So it is a nonlinear system. And you see here it is a function of time 2t. So it is a time variant system. It is described by using differential equation. So it is a dynamic system. Okay, students? Yes. So in this way, by using the logics, you can tell that whether the system is linear, time invariant and dynamic system. Okay, students? Yes. Let us take 1 minute break. Welcome to the session, students. Last classification, stable and unstable systems. Before moving to stable and unstable systems, you have to know first of all what is meant by bounded signal. What is meant by bounded signal means if a signal amplitude is always finite throughout the time interval from minus infinity to plus infinity, that type of signal is called bounded signal. What are the examples of bounded signal means sin t. Sin t is an example of bounded signal. Always the amplitude lies between minus 1 to plus 1. Similarly, cos t. Cos t is also bounded signal. Okay? Yes. So u of t is also bounded signal. Del of n, discrete case. What is amplitude? 1. It is also bounded. And u of n, etc. All these signals are bounded signals. Now, unbounded signal. What is meant by unbounded signal means even at any one time instant, signal amplitude tends to infinity. That type of signal is called unbounded signal. Example, ramp signal R of t. What is the amplitude of this signal at t equal to infinity? Infinity na? Yes. So it is an example of unbounded signal. Similarly, del of t. Del of n is bounded, but del of t is unbounded. Why? What is the amplitude of this signal at 0? Infinity. So it is an example of unbounded. And e to the power of t. What is the amplitude of this signal at infinity? Infinity. E power infinity is infinity, etc. This type of signals are called unbounded signals. Okay? Yes. Now, what is meant by Bibo stable system? Means for a bounded input, for a bounded input, if we get bounded output, then system is called Bibo stable system. System is called what type of system? Bibo stable. Okay, yes. When a system is said to be Bibo stable, for a bounded input, if we get bounded output, system is said to be Bibo stable. Okay, students? Yes. When a system is said to be unstable, system is nothing but for a bounded input, if we get unbounded output, then system is said to be unstable system. Okay, yes. For a bounded input, if we get bounded output, system is stable. For a bounded input, if we get unbounded output, system is unstable system. Now let us see with few examples, students. Yes. Y of t equal to dx of t by dt. You have to apply one bounded input. What is the example of one bounded input? X of t equal to u of t. Is it bounded signal or not? Yes. What is the output you will get? Y of t equal to du of t by dt. What is the differentiation of unit step impulse signal or not? Yes, del of t. So is del of t is a bounded or unbounded? Unbounded. So system is a unstable system. What type of system it is? Unstable. Okay, yes. For a bounded input I am getting unbounded. Next. Y of t equal to minus infinity to t x of tau d tau. Here you substitute one bounded input. X of t equal to u of t. Then what is the output you are getting? Y of t equal to minus infinity to t u of tau d tau. What is the integration of unit step? Ramp. Ramp is a bounded or unbounded? Unbounded. So for a bounded input I am getting unbounded output. So system is said to be unstable system. What type of system it is? Unstable system. Okay, students? Yes. Next one. Y of t equal to sine of x of t. Yes. For this, how to check is, see here, sine of bounded is nothing but finite value or not? Yes. So sine of finite value I am applying. Sine of finite always results finite only. Sine of finite always results finite. So it is a Bibo stable system. Okay, yes. Sine of finite always finite. Next. Y of n equal to e power x of n. You have to apply bounded input, means finite value. E power finite always results finite only. Okay, yes. So e power finite equal to always results finite only. So it is a stable system. Okay, yes. So in this way, you can verify the stability of the system. Now, let us see few KPTCL previous year's questions from this system chapter. It is a KPTCL 2018 question. Just after listen this class, just by using the logics, you can able to tell. Tell me students, y of n equal to x of n into cos omega naught n. Already I have solved this problem. Tell me, he is asking the time variance and causality. Okay, yes, tell me here, y of n equal to x of n into cos omega naught n. Tell me how to calculate y1 of n. Wherever x is there, delay by n naught, x of n minus n naught into cos omega naught n. What is y of n minus n naught? Wherever n is there, replace with n minus n naught. So cos of omega naught into here n. Cos of omega naught into n minus n naught. So are both are equal? No. So y1 of n is not equal to y of n minus n naught. So system is a time variant system. Is it causal or non-causal? Tell me students. Cos omega naught n is not a function of input. No need to verify this. So here n is there, here n is there. Present output is depending upon present input only. So it is a causal system. So finally system is time variant and causal. Yes, time variant and causal. So what is the right option students? C. Yes, C students. After listening the session, you can easily solve these problems, okay? Yes. Let us see one more question. Yes. See students, system described by the difference equation y of n equal to x of n minus x of n minus 3 plus x of n minus 5 minus x of n minus 7. The impulse response of the system is, actually it is not related to system chapter, it is related to LTI system chapter. There you are getting impulse response concept. But why I am telling this question in this chapter? Because there is one link is there between system chapter and LTI system chapter. What is that link is, if the system is a LTI system, if x of n equal to del of n, then y of n becomes h of n, impulse response. This is valid only for LTI system. What is mean by LTI system? Linear and time invariant system. Means, first of all, you have to verify that system is LTI system or not. Means, if it satisfies linearity property as well as time invariant property, system is the LTI system. Verify students. It is a difference equation. Is there any nonlinear operator is appeared? No, no, no. No nonlinear operator is appeared. So it is a linear system. Is there any time invariant operator? Means, what are the coefficients? 1, 1, 1, minus 1, 1, minus 1. All coefficients are constant, so it is a time invariant. So it is satisfying linearity and time invariance, so it is a LTI system. So for a LTI system, you can replace x with del and y with h. Then what is the impulse response of the system? H of n equal to del of n minus del of n minus 3 plus del of n minus 5 minus del of n minus 7. Yes, this is the impulse response of the system. Okay, impulse response concept is different, but if you know that it is a LTI system, in this way you can easily obtain the impulse response of the system. Link is there, okay? Yes, it is KPTCL 2018 question. And one more question, see students. One more question. The system represented by y of t equal to e power x of t. It is a KPTCL 2011 question. Linearity and time invariance is asking. Tell me students, directly how to tell. Exponential operator. Exponential operator is a linear operator or non-linear operator? Non-linear. So it is a non-linear system and y of t equal to e power x of t. Already we have solved now. What is y1 of t? Wherever x is there, delay by t naught units. Yes. And what is y of t minus t naught? Wherever t is there, replace with t minus t naught. Yes. Both are equal. y1 of t equal to y of t minus t naught. So it is a time invariant system. Time invariant system. So finally the given system is non-linear and time invariant system. So these are the few questions asked in the previous KPTCL exam. Okay, students? Yes. So just by listening these lectures, you can easily able to solve the problems in the KPTCL exam in the system chapter. Okay, students? Yes. So thank you for watching this session. Thank you, students.